Hi, this is Rajesh. Today we are going to do quadratic equations, exercise 5.3. In that last problem, that is 12th problem. If a polygon of n sides has n into n minus 3 by 2 diagonals, how many sides will a polygon having 65 diagonals? Is there a polygon with 50 diagonals? See, here we need to find sides of a polygon when it has 65 diagonals in the first part. Next part, we need to find is there any polygon with 50 diagonals. See, they gave number of diagonals is equal to 65. Formula to find diagonals is n into n minus 3 by 2. So first of all, according to problem, what they give, we will write number of diagonals is equal to 65. What is the formula to find number of diagonals? When you know number of sides, n means number of sides, at that time number of diagonals will be n into n minus 3 by 2. So that only here we will write n into n minus 3 by 2 is equal to 65. This is the formula to find number of diagonals. So number of diagonals is 65 again, where n indicates number of sides of a polygon. At that time, formula to find number of diagonals is this one. N into n minus 3 by 2 is equal to 65 according to the problem. Now we can write this one as n into n minus 3 is equal to 65 into 2. So n into n square minus 3n is equal to 65 2's 130. Now this can be written as n square minus 3n minus 130 is equal to 0. Now it is in the form of quadratic equation. Ax square plus bx plus c is equal to 0. Here we need to find roots of a quadratic equation. Take first term by using factorization method I am doing, and the last term, the product is minus 130n square. Product should be equal to minus 130n square and sum should be equal to minus 3. So here take prime factors of 130, 2 table 65. Next take 5 table 13s. 2 5s are 10. 10 into 13 130. 10 here minus 3n is there, no? Minus 13 plus 10 minus 3 we will get. We can write minus 130n square as the product of minus 13n and plus 10n. When we add these two terms, we will get minus 3n. When we multiply these two terms, we will get minus 130n square. Now, in place of minus 3n, we can write minus 13n plus 10n minus 130 is equal to 0. So, here we need to take n is common. Now, n minus 13. Here we need to take plus 10 is common. N minus 13 we will get. Again, n minus 13 is common we need to take. So n minus 13 into n plus 10 is equal to 0. Here the product of these two expressions is equal to 0. At that time this may be 0 or n plus 10 may be 0. So that only we will write here n minus 13 is equal to 0 or n plus 10 is equal to 0. So n is equal to 13 or n is equal to minus 10. See, n is equal to minus 10. It is negative value. Number of sides of a polygon we won't get in negative numbers. So we should not consider this one. We have to consider n is equal to 13 only. Therefore, if the number of diagonals of a polygon has 65, if the number of diagonals of a polygon has 65, or else if the number of diagonals of a polygon is 65, then the number of sides, then the number of sides of a polygon is 13. So here in this problem we have completed half of the problem. Next, remaining half also we need to complete. That is there a polygon with 50 diagonals? See, when they give 65 diagonals, we find how many sides we will get for a polygon. 13. Like that only here they are giving, is there a polygon with 50 diagonals? Now they are giving 50 diagonals. We need to identify, can we get a polygon with 50 diagonals or not? If we get, how many sides it has also we need to find. So that only here, now for this number of diagonals is equal to 50. So formula to find diagonals is n into n minus 3 by 2 is equal to 50. Now n square minus 3n is equal to 50 into 2, 100. Now this can be written as n square minus 3n minus 100 is equal to 0. Now by using factorization method, we can't find roots of a quadratic equation for this one, isn't it? Because take first term and last term, we will get minus 100 n square, and product of two terms should be equal to minus 100 n square, and sum should be equal to minus 3n. We won't get any factors like that. So that only we have to go for factorization method. That is, we can't find roots by using factorization. So we need to go for formula method. See, that is x is equal to minus b plus or minus square root of b square minus 4ac by 2a, isn't it? So in this, a is equal to 1, b is equal to minus 3, and c is equal to minus 100. Now first we need to find discriminant, that is b square minus 4ac value. b square minus 4ac. So b is nothing but here minus 3 whole square minus 4 into 1 into minus 100. Now 9 plus 400 is equal to 409. So we got discriminant value b square minus 4ac is 409. Now we need to substitute in this one. So here x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Now minus of minus 3. B means minus 3. So minus b is here. Minus of minus 3 plus or minus square root of 409 by 2 into a. What is the value of a here? 1. So here we will get 3 plus or minus square root of 409 by 2. See, roots will be 3 plus square root of 409 by 2 and 3 minus square root of 409 by 2. See here, we won't get any side like 3 plus square root of 409 by 2 and 3 minus root 409 by 2. Therefore, here in this problem, we won't form any polygon with 50 diagonals, because here we got the values 3 plus square root of 409 by 2 and 3 minus square root of 409 by 2. Those are not whole numbers. So number of sides of any polygon will be like 3, 4, 5, 6, like that we will get. But here we can't write those numbers like this. Here 3 plus square root of 409 by 2, we can't write like that. 3 minus square root of 409 by 2, we can't write. So that only we can't form any polygon with 50 diagonals. Okay, thank you.